And good evening, and welcome to our October 4th, 2025 edition of the At Home Planetarium Show. I am your host, planetary geologist Scott Harris, and whether you're watching live this evening or later recorded, I am very happy to have you with us. And feel free to put any questions you have into the live chat, and I'll try to get to those as I can. And if you are watching in the recorded version, you're welcome to put things into the chat or to email me any questions at southernspacrocks@gmail.com. And so it is International Observe the Moon Night, and for that we're going to take a special tour of the moon and maybe even look at some of the details of lunar geology. But before we do that, we're going to go and take a look at our overall night sky. After all, this is an at-home planetarium, and this first part is powered by the software Stellarium. And to join Stellarium here, we'll hop out to our nighttime sky, and we will see if I can get this wide view here. And as we look off to the west, just after sunset, which here in the along the East Coast is kind of about right now. We're going to head out, and I'm going to pause this so it's a little easier to navigate. But this is the sky here in the Atlanta area about 20 minutes from now. And as we look off toward the west, following the setting sun, we're going to be treated to another sun there, but very far away, and that is the bright star Arcturus, the brightest star in the constellation of Boötes the herdsman. And if you have a hard time seeing a herdsman there, I don't blame you. But maybe you see a bit of a diamond shape there above the Arcturus. If you are not watching this live, I know some people said they wish they could, but you're looking at another diamond right now, the baseball diamond, with some of the playoff baseball going on across the country. If you have a hard time spotting this, you can look around to the northwest and spy a feature we see in the sky that everyone knows, and that is the Big Dipper. That is an asterism, not a constellation. That is just a star shape. But this star shape, this asterism, happens to be part of a very famous constellation called Ursa Major, the Great Bear. It's actually the back and the tail of that bear. We'll see that in a little bit more detail in a moment, but my astronomer friends love to point out that you could take that tail, or the handle of the dipper, and you can make an arc, and arc over to Arcturus. And between there and the dipper, we see the that diamond. I'll help you out here a little bit with the artwork and the constellation symbols. Now maybe you see that. I sometimes think it looks like a bit of a kite there in the sky, with the kite here and the Arcturus as the decoration on the tail. As we come a little bit higher in the sky, we will find here the Little Dipper, which is actually the back of the tail of Ursa Minor, the little bear. Maybe looks a little bit more like a raccoon of sorts. But I'm going to draw your attention up here toward the top of the sky with this bright bluish white star Vega. Vega is the brightest star in the constellation of Lyra, the harp, and is in fact one of the brighter stars in the nighttime sky. As we look a little bit higher, we'll see another bright star here, Deneb, and over here the bright star Altair. And these, if I take the artwork away, we will see that these make a triangle in the sky. This is actually what astronomers call the summer triangle. Yes, we're in the autumn now, but it holds on to the sky until the winter months. And it forms a nice triangle there that is important in a number of ways, including the fact that we can use it to identify where the Milky Way is stretched out across our sky if we're in a light polluted area. That may be important if you want to try to take a photograph of the Milky Way. You don't have to be able to see it visually to be able to get a good photograph. You just have to know where to aim your camera. And so as we look here at the summer triangle, we have Vega and Lyra the harp, as I said. Altair is the eye of Aquila the eagle, and the neb over here is the tail feathers of Cygnus the swan, and you might see the wings outstretched here and the neck pointed here to the southwest. Well, that's how you that is how you want to actually identify the where the Milky Way is. The swan is flying with this outstretched neck there right to the south along that milky region of stars that is the outer bands of our spiral galaxy viewed from Earth. And again, if you want to see a little bit of the artwork to help you out, we can do that. Now, very clearly, you see the eagle, the swan, and the harp. And one of my favorite constellations over on the other side, if you want to make another diamond, is Delphinius, the dolphin, just there around to the a little farther to the north. So I'll get rid of that artwork, and I'm going to swing back down to the horizon. We'll look back to the southwest now. We'll see here the bright star of Antares, a red supergiant, and that is, of course, the brightest star in Scorpius, the scorpion. We see his claws coming up here, his tail with a stinger here, and this region right in just a little bit above and around to the south at this time of his tail, that is looking directly back into the heart of our Milky Way, where there's a supermassive black hole called Sagittarius star by my astronomer friends. And right next door here in the sky is my favorite constellation, that is Sagittarius the Archer, because, well, I have a mid-December birthday. And as we swing around a little bit farther to the east, we will see the object of everyone's affection this evening, our moon, in its first quarter phase, and we'll talk about that a little more in just a moment. Right next door, you might be able to make out Saturn, our ringed world here. And I'll give us a little bit of a zoom in here to get a little bit more of the view that, maybe you get through a telescope. We'll just try to get in there just a little bit. And you may see a bit of a oblong disk there rather than a nice tight disk like if you were looking at Jupiter or Venus because of the rings. But we also, if you have a pretty good telescope, you might be able to make out some of the moons around Saturn, including its largest satellite here, Titan, which actually is larger than Mercury. And for many of you have heard me say before, for us planetary geologists, that's a planet in its own right, along with the other 6 larger moons there in the Saturnian system. And we will, that looks like your best bet tonight is to perhaps see Titan. Some of the others at this point anyway are sort of obscured by looking directly at the planet itself. So I'm going to come back here so we can see our horizon, and we'll move around to the northeast, and we might be able to see some other neat features over here. This is a very rich sky early in the evening right now. You may make out there to the east a giant square, and that is the Great Square of Pegasus. That is the back and the wings of Pegasus, the flying horse, that if you remember your Greek and Roman mythology, or as I sometimes say, the Clash of the Titans movies, you will recall that Pegasus came to the aid of the hero Perseus to rescue Princess Andromeda. And she's over here, tied up or chained up by the sea monster Cetus, or in the movies, the Kraken. But as I often point out, that's mixing mythologies. That's mixing Greek and Roman and Norse. That's too many. Don't go there. So we have Andromeda here with tied up by Cetus, and there are her chains there as her arm reaches out toward the north. And if you can follow the body there of Andromeda and find the arm, it's going to be pointing away from Saturn. I'll get rid of the artwork here, and if you're in a reasonably dark sky, you might be able to just make out a fuzzy patch of light here. That fuzzy patch of light is the Andromeda Galaxy, our nearest spiral neighbor. And some of you know it is rushing toward us, and so several billion years will actually collide with our Milky Way. But most of the models would just say it'll get brighter outside because there'll be more stars for you to see. Some in the Andromedas sharing with ours here in the Milky Way, and then they probably will just pass right through each other over some couple billion years or so. So I'm going to go ahead and focus in on the moon here, and we'll get a much better view of the moon here shortly. But we'll notice that our moon here is we see most of the near side. We're actually in a I misspoke before. We are not at first quarter. We're actually in a waxing gibbous phase here, past first quarter. Sometimes these observe the moon nights is sort of customary to have them around first quarter because that gives you maximum contrast to see some of the features here on the surface. But we're a little bit past that now, and we have a almost full, very bright moon here in the sky this evening. And we're going to focus on some of these features with our open space program coming up in just a moment. But I'm going to come back here away from that for a moment and go ahead and look up toward the top of the sky again and turn the artwork on one last time, and just to allow you to see those pictures that the ancient astronomers visualized there in the sky. And we'll now leave that and come back here just for a moment. And now I'm going to take you out to our solar system with our open space platform. And if you would like to, you are able to download this yourselves. It's an open source program available from the American Museum of Natural History's Hayden Planetarium. Great guys and ladies up there who have spent a lot of time over the years putting this together, and I've been very fortunate to be able to get some instruction directly from them. Actually, back right before the pandemic hit in 2019 into 2020, I'd gone up to the American Museum to explore some of the features of this program, and I've been using it ever since. It's a great program. And a lot of credit to Carter Emmett and his staff there with the Hayden Planetarium to be able to have this and use it and share it out to other planetariums around the world. And I have sort of docked us here at a ways away from our sun. I sometimes like to visualize what it'd be like if you were an alien visiting our solar system for the very first time, and you could just see the glow there of our sun. You might not know there are any planets at all. Maybe at this distance you're running into some of those icy blocks out in the Oort cloud that you would be able to identify as some sort of objects, solid objects, ices that are orbiting that glowing orb there at the center. But most of those will be probably pretty stable, not particularly in a hurry to come cascading in toward the sun to create some of those comets that we'll be talking about in the next couple of weeks, as you are able to enjoy a few of those perhaps in our early evening and late morning skies. Or early morning skies. But we're going to go ahead and come in toward the sun, and just imagine that bright sun showing up. That light would overwhelm you if you were visiting us, and well, it would be sort of twilight out at those distances. We would venture into that area called the Kuiper Belt, where many of the icy worlds hang out that are a bit like Pluto and Charon. And we see the orbits of our classical 9 planets there as we venture in a bit farther. We get into about 20 AU, or 20 astronomical units, 20 times the distance of the Earth to the Sun. And at those distances, we will get very close here to the orbit of Pluto and Neptune. And that's where we're going to we'll bypass those for a moment and just race inward, seeing the passing Jupiter and Mars. And we see Earth's orbit there, Venus a little bit closer to the Sun. And we enter the Earth-Moon system. We see the orbit of the Moon going around the Earth here. And as we approach the Moon, we'll get a fantastic view, largely powered in these images by the Lunar Reconnaissance Orbiter and the LROC camera, as we call it, that is hosted by my undergraduate alma mater, Arizona State University. Just an incredible history now of imagery and scientific data from the Moon, from that craft. Some of the imagery here is also supplemented by other spacecraft from the U.S. and our partners around the world, particularly Japan with the Cayuga mission a number of years ago, gave very high resolution imagery for us to look at. We also have imagery now from China. We have imagery, not recent imagery, but from Russia, but we have some from the, some data from the former Soviet Union. We also have abundance of mineral data that has been provided by the Indian space program. So the Moon is a place for us all to cooperate, and hopefully it will remain that way for a long time. As we look around on the near side, and if you're not familiar with the Moon, other than the fact it's up there in the sky, there's no dark side and light side. Well, there are at any given time, but they're changing as the Moon actually does rotate on its axis, just like Earth does, just like everything of size here in the solar system rotates around on an axis. The Moon happens to be rotating around on its axis, though, at exactly the same rate that it revolves around the Earth. So we're stuck seeing the same side all the time from our vantage point here on the ground. We have to have a spacecraft to go up and look at the backside of the Moon, if you will, or what we call the lunar far side. So we have a near side, a far side, not really a light and a dark. And when we're close to full moon here, we have most of that near side bathed in light. The temperatures near the equator get up to over 100 degrees Celsius. So when you see these, when we have these plans for future astronauts going back to the Moon, climate control is a big deal, right? It gets hot on the Moon, and you don't want to be in that searing heat without the proper protection. So your spacesuits are have coolants and refrigeration systems to keep the astronauts comfortable and in appropriate conditions for a person. This is also worth noting that that's the daytime. If you go across that divide into the dark, that's called the terminator. It drops off very fast. It goes from, again, around 100 to 110 degrees Celsius at the equator, and immediately dropping down to around minus 180 degrees on the backside, in this case, on the far side as we cross the terminator. But that is just an incredible temperature difference. It's not the most extreme, though. That likely is at Mercury, and we may mention that a little bit later as we take a quick tour of the entire solar system at the end tonight. So, I've been just driving around looking at this near side, and one of the things you can't help but see as you look up at the full lunar disk are these large circular regions. And if you're out there with me and know what those are and want to just put that into the chat, it would be kind of nice. But those are our giant impact basins. We believe that most of the ones that you see here were formed in a period of time between about 4.1 and 3.8 billion years ago. Some people propose that there was actually a late heavy bombardment of the Moon. Others suggest that, well, this is just the terminal phase, the end of a much longer period of bombardment that went on in the early history prior to around 4 billion years ago. Maybe some of those, there are other basins that are just obscured by the new basins that were formed on top of them. But Perhaps you've heard of the man in the moon. Most people sort of describe that man something like this, where you see the two eyes of the man here. Some other cultures, including the Japanese I mentioned earlier, see that as the ears of a rabbit. And as we look here at two of the larger ones, this is the Imbrium Basin. Next door is the Serenitatis Basin. And then below that is a dark patch that some people ascribe to being a basin and some people don't. But this is the Tranquillitatis region of the moon. Famously, the southwestern corner of this was the landing site for the Apollo 11 mission, the first time that people landed on the lunar surface, right down in this area. And these large dark areas that, like Tranquillitatis, and the dark patches filling the large basins, those are lava flows. Basaltic lavas for the most part, very much like what we'd find on Earth's seafloor. You probably have seen basaltic lavas pouring out, at least in videos in places like Hawaii. The chemistry there is a little different than the chemistry you'd find here. These are, for the most part, much more akin to our ocean floor basalts, but there's some variety too. Some of them are really weird, might even say some of them are creepy. The geologists out there will get that joke, but we may talk about that a little more as we go. But these are two of those large basins, and we can swing around and find some others here. The Crisium Basin filled with the Mare Crisium. Again, Mare is the word for sea, Latin for sea, because ancient astronomers looked up and thought that these might be actual seas filled with water or some type of liquid. Well, they were liquid at one point, but not filled while those astronomers were looking. These were the great lava plains that go back to around 3.8 billion years in places, and range in age from that down to perhaps as young as a million years, or not a million, 1 billion years. There may be some that are hundreds of millions of years old, but that's debatable. But from about a billion years back to about 3.8 billion years, we find these lava flows. The best dates that we have actually come from a number of the Apollo missions collecting samples in these Maria around in these basins, and also a little farther south here on the edge of Oceanus Procellarum. But the youngest materials, those materials that the Apollo collected, most of them were in this sort of 3.6 to 3.8 billion year range. The youngest materials actually are over here. As far as what's actually been collected, those were collected by the Chang'e 5 lander and sample return mission from the Chinese Space Agency. And we imagined that the younger materials would be here based on the density of craters here. Like, older surfaces collect more and larger craters, and younger surfaces have fewer large craters and fewer craters overall in many cases. And we'll see this area a little bit better here. This is one of the younger areas on the moon called the Aristarchus Plateau. And Chang'e landed over here very close by and actually confirmed dates around 2.5 to 2 billion years, where we had estimated that the Aristarchus Plateau was around that 2 billion year range. And just to help us out here, I will go ahead and see if we can, we'll get a little light on the subject here. We have a way here of turning off this shading of the sun. And now we can see everything bathed in full light. Easier to see now. And we see that far side with all of its craters. And hopefully some people are getting to enjoy this evening. Here in the Atlanta area, at least, it is quite cloudy outside at the moment, and not a great time to observe the moon. So if you're observing with us, I appreciate it. But now you can see this very bright region. This is one of the brightest features on the moon. If you look up at it, you may be able to see that with your naked eye. And the reason is these very bright impact ejecta around the crater Aristarchus. But you may also notice that this is a raised plateau. It's setting up high, and you might imagine that if magmas were underneath, they would well up. They would low density. They would create a buoyant crust there on the moon and push that area up. And we think that's exactly what has happened. And here in the middle of that plateau, we see this snake-like valley. This is Schroeder's Valley. That is a large outflowing of lava, again, maybe around that 2 billion year time frame. And inside of that, there's a narrower lava channel, or really what must have been a lava tube when it was flowing. And I'll talk with you a little bit more about that in a moment as well. But this is a one of the younger volcanically active areas. And the other thing I thought I would show you this evening is a few of the landing sites, some that are easy to find. One of my favorite ones, again, because of the lava tubes involved. And I used to explore lava tubes to compare them to lava flows on the moon and Mars and even Venus to some extent. And so as we look along the edge of the Imbrium Basin, we're looking for a lava tube. Can you spot it? Well, the roof of the tube has broken down, at least for the most part, but there may be some areas that are still roofed over, and imagine there could be a cave in there that future astronauts could use for protection from micrometeoroids or radiation from the sun. This is Hadley Reel, and as if we look here, we can see that it emerges from a volcanic vent. You might imagine big high fountains of lava, like the big fire fountain curtains in Hawaii, coming out here and flowing out, forming a lava tube to feed that lava off to the north. And eventually that lava flows out and forms a great lava plain here. And this was the site of the Apollo 15 mission. The Falcon landed here. I'm reminded of this is they named their landing craft Falcon because all the members of the crew were Air Force pilots, and of course that's the mascot there for the Air Force. And this is where Commander Dave Scott famously did the classic Galileo physics experiment of free fall, taking a feather and a hammer and dropping those at the same time from the same height, and finding out that, sure enough, without air resistance, free fall does not depend on mass, and so the hammer and the feather hit the lunar surface at exactly the same time. So this is this shows you the power of the volcanism here on the lunar surface. Again, going back to that more than 3 billion years. But in contrast, something 3 billion years old, I'm going to try to find for you a different kind of feature. And to do that, I'm going to have to kind of back away from Imbrium for a moment. And I'm going to, let's see if I can dive back in here. This was a little bit tough to find. Let's see. We're looking for any evidence of younger volcanism. You might notice that in some areas there, the Mare have these mounds on them, and we think that those might be some type of small shield volcanoes, or even some sort of later domes made of more viscous materials than you normally find in these basalts. So maybe those are younger by a little bit. But let's see if we can find any evidence of anything super young. And again, I'm going to have to move backwards here so I can get a good view of, find this by looking at Imbrium and Serenitatis. Now, what I'm going to show you here, you can look at this area with your telescopes, and you're not going to see what I'm about to show you because it's tiny compared to the resolution of your scopes, and even with the better scopes that you would have available. So this is really a spacecraft feature that I'm looking for. Let's just see if we can dive in here, and we'll aim for this crater here, and we'll come a little bit northeast of that crater, and we'll be here in some of those ancient lava flows. And now we're going to see a little patch that looks a bit like some sort of scallop there. And the resolution on this, actually, if we waited a little bit of a moment, it may pop in. But already you can see that this is, there's a little smooth area here with no craters. I'm going to give you a little bit better view of what that looks like. And if you'll give me just a moment here, I'm going to switch over to a PowerPoint slide and get a, we'll take a little bit better look. And let's hop over there now. And this is called the INA structure. And let's see if I can, well, it didn't let me do that. So I'm going to actually move through some of these very, very fast so I don't have to go. We may come back to a few of these in a moment. I just wanted to have this as a little backup for any questions you might have this evening, as well as to point out a few special things. But as we look for the young volcanism on the moon, our attention gets moved to these to this structure like INA, and this is what I was aiming for here. This is what that feature looks like from orbiting spacecraft. And notice these very smooth areas that they kind of look like they're just a continuation of the lava flows around, but then this sort of very Swiss cheese-like. I mean, we're talking about the moon, right? The moon is not made of cheese, but this part, you might fool someone. These are actually low areas around highs. These are flat plateaus that are dark and cratered. But then a lot of material that's been sculpted around them is actually material that's collapsed. And a number of planetary scientists have looked at this and concluded that based on the number of even small craters that will be hitting this over time, this must be a very young feature, perhaps on the order of 100 million years, perhaps on the order of millions of years. It's not absolutely clear. What is clear is that it's young. Yeah, there's a lot of discussion about how this would form. Is this an area where there was some type of gases that were in the lava that then escaped, leaving this behind? Or is this an area where relatively recent extrusions of gas have made their way out of the lunar surface and out to space? And that's what's going on, and this is a type of volcanism that could be super, super young. There are also some lava flows on the moon that appear to possibly be very young, again on that 100 million year time scale. And this is what they look like. You can look through the Lunar Reconnaissance Orbiter data and even old lunar orbiter data, a number of data sets trying to find these, as myself and some colleagues try to do from time to time. So I'm going to actually come out of this for a moment and just take you back to a few things that I think are worth looking at. First of all, just in case you didn't know it, the rocks that we have gotten back from the moon, 381 kilograms. What's that? Something on the order of a little over 800 pounds of material were returned by the 6 Apollo missions that landed on the lunar surface in the late 60s and early 70s. The former Soviet Union also returned a little bit of material from some robotic spacecraft, only 0.3 kilos. Their return from a few of their Luna spacecraft. And since that time, we've also had the opportunity to examine other pieces of the moon via lunar meteorites. Now, don't mind that Martian sort of intruding on things there. But these are good examples of lunar meteorites that were ejected off the moon by asteroid or comet collisions and then found their way to land here on Earth. So that supplements or augments our data that we have available about the moon. It's been very, very useful. And I had the opportunity a number of years ago to examine and photograph and actually video some of the lunar samples under the microscope. These are what some of the thin sections look like, where the rocks are ground down very, very thin, put on microscope slide, polished, ground down so thin you could get light through them, and then polished some more. and ultimately put in, for the lunar samples, put in these very, very safe pieces of glass. They are fragile, but they have some guards around them trying to make sure no one damages them. But these are, the replacement value is, these are irreplaceable, right? There are educational sets, these that go around, and research sets that go around, and it's often a bit humorous, a bit frightening, that when you get to handle these, often there's a little bit of an instruction sheet that tells you what the replacement cost for each slide is, and it's something on the order, as I recall, about $14 million a slide. That is, accounting for all the money to actually get the mission up there and get the samples. So you try to be very, very careful with these. But as I was talking about before, and I'm not going to show everything tonight, but let me go to Apollo 15 again. Apollo 15 was, you had, again, Commander Dave Scott, Jim Irwin, and the pilot that was left up in the command module was Al Warden, who I've had the pleasure of meeting before he passed away. Of that crew, Dave Scott is still alive. His daughter Tracy is a sociologist with Emory University here in the Atlanta area, and she's been great, helping in the past with telling stories about growing up being the daughter of an astronaut. If you ever have the opportunity to hear her speak, it's quite educational, entertaining. But Dave is again still, as I said, still with us, and this is the view where they landed. And what I was talking about before are lava tubes, and this is what they look like on Earth. In Hawaii, you look down in these skylights, and then sometimes they drain out, leaving caves behind. And these tell us a lot about the mechanics of the lava flow. But on the moon may very well be places to seek refuge in the future. Another important, well, all these missions are important, but for those of us in the Atlanta area, one that is sort of near and dear to us is Apollo 16, because the commander of that was a gentleman named John Young. John, one of the most prolific astronauts we ever had, was grew up in part in the Marietta area here in Georgia, and then ultimately attended Georgia Tech. And I sometimes have to let's see if I can actually, it's not going to let me play that right now, but let's see if I can come right, and it actually will here. This is John driving the lunar rover across the surface, so a little wild Georgia Tech driver there, real rambling wreck, you might say. And John, I also had the pleasure of meeting a couple times, a very classy gentleman and very dedicated engineer and scientist. And they landed in an area here that I'm going to come back here so I can show you that. They landed in this area that is part of the Lunar Highlands. You see the dark maria that we mentioned before, but here is the old lunar crust, made up of largely the rocks called the northicites. And if we look at those under the microscope, they're pretty wild to look at. And I'm going to come back to this. So this is looking in plain polarized light through a special polarized light microscope. And then this is what happens when you have two polarizing filters 90 degrees from each other. It's a beautiful rock to look at under the microscope. It's a beautiful rock to look at anytime. It would have been great to be there and in John's shoes and be able to see what this lunar highland was made of. But they brought back these samples that we're able to enjoy. And also in that region, all these rocks are old and busted up. They've been impacted many times. So it's not just nice, pristine samples of an orthosite. There are many little melt spherules and blobs that are created when you have collisions with this by asteroids and comets. And ultimately you get these busted up breccias, this brecciated soil or regolith that we call it, spread across the area. And again, right here in this area, in between Oceanus Procellarum and Tranquillitatis, where Apollo 11 had landed earlier in the Apollo program. So just a little bit of geology there. And then also I'm going to mention Apollo 17. Here we have the Taurus Littrow, the Taurus Littrow Valley on the edge of Mare Serenitatis. And this was commanded by Gene Cernan, who is unfortunately no longer with us, but it also included Harrison, or as we call him, Jack Smith, who was the only geologist ever to go to the moon, and so a very special person for many of us in the geologic community. And this is where they landed, as you see Mare Serenitatis there, Mare Tranquillitatis, and you can imagine their descent into the Taurus Littrow Valley. And this was a region that was potentially very important for understanding young volcanism, relatively young volcanism on the lunar surface, and also some of the tectonics. Because of these large scarps, there was material that seemed to have been fallen down those scarps at some point in the history of the moon, and so this was a great place for geologists to go. And so there's Jack on the moon, scooping some rocks for examination, and also some opportunities I've had to kind of hang out and talk with Jack over the years, along with my former advisor Pete Schultz, who literally wrote one of the books on the moon. So there's a lot of accumulated lunar knowledge there in that picture that I was able to enjoy. Jack and Gene had a great deal of fun on the moon too, and you may have seen this NASA video before of them trying to sample the rocks and kind of falling over there in the lunar gravity. There's another video of them sort of bouncing along, singing on the moon. But this area was really super important because, again, it's volcanic history, showing you not only the very typical basalts, just a few examples of what those look like under the microscope, but as Jack famously exclaimed here, he saw orange soil. And this orange soil turned out to be composed of little tiny orange beads of glass that we now understand were erupted from fire fountaining volcanoes back around 3.6 billion years ago. And if you want a good Halloween picture here, here's a good one, a little ghostly action going on in that mineral grain. But the orange here, these are little beads of glass. And again, this is how they may have formed on the moon, much like you see here in Hawaii. But just incredible delicate details here. Some crystals forming very rapidly from, or as we say, quenching from the melt to form these intricate features. So a little bit of a deeper insight into the geology there, as I'm going to go back to the lunar surface here for just a couple more minutes before we take a little whirlwind tour through the solar system. And so I'm going to back away from that Ina structure there that may be young volcanism, very young volcanism. And let's take a look at a couple of the younger craters, and I say younger sort of jokingly because this is much younger than this large basin. This crater is about a little over 800 million years old, and that is the crater Copernicus. And Copernicus is sort of a bit of a time marker for the surface of the moon. And you may notice that if you look at these wisps out across the lunar surface, those are ejected material from this crater, and it crosses a lot of real estate. So if you can go to these areas it crosses and measure or collect rocks to get accurate radiometric dates, then you have a way of correlating those ages with other parts of the moon that you didn't get to go to by whether or not the ejecta from Copernicus crossed it, and in this more detailed relationships of that ejecta to those rocks. So it's a very important crater in establishing a timeline on the moon. It's about 93 kilometers across, and as we dive down deep inside, you'll see the hallmark features of a complex impact structure. You have not just a hole, but you have a central peak or series of central peaks there that are sticking up from the floor. This is where material has, once the rock is compressed by the shock wave and the impact, it creates the hole from compression, and then gravity takes over and everything comes flowing back in, and it causes material in the deep beneath the floor to be uplifted in the center. And as we go in, where we're used to seeing those big basins filled with lavas, a lot of the volcanism was over by the time this was even created. So what's this dark material on the floor of it? And it just has incredible structure to it. Sometimes you'll see some intricate cracks and sort of mounds and blobs and bulbs. These are the impact debris. These are impact breccias and a lot of melt. There's a impact melt sheet in this in the floor here, and sometimes it sort of drapes down off of the Central Peak mountains, and just the resolution that the LROC's camera has given us is just incredible. And next door, we there's a kind of a similar looking crater, and you'll notice the very bright ejecta around this. This is the crater Kepler, and we can zoom in a little bit on that one. And sometimes it just depends on your how fast data is streaming. This is a very powerful program, bringing in data from what's called the Planetary data system, and it really is up to date with the latest, greatest imagery and data from our space missions out there in the solar system, some long ago, some ongoing. As we come down to the south, though, toward the South Pole, we're going to see another crater of similar size. It's a bit smaller there than Copernicus, but it's very well defined, and if you look carefully, you may see some wispy materials going out across the lunar surface. Those are bright rays. They actually don't look as impressive in this view because there's so much other detail in the imagery. This is much more impressive if you just go outside, like hopefully you're doing tonight, and look. You'll see these bright rays that extend out a very long distance, even all the way up here to Serenitatis. This is a ray from this crater called Tycho, all the way down here. And one of the ways we get an age on Tycho is by dating some of the ejected materials from this, and it's estimated being about 110 million years old. So while dinosaurs were here on Earth roaming around, they may have seen this crater formed by a large collision. And if we zoom in on that, we get to see some of the terracing, and sometimes you can get the resolution so high you can see some boulders that actually settled back down there on the top of the Central Peak. And then finally, because we're getting ready for the return to the moon here in the future years, we hope that happens. It's now been it's all going to be 53 years in December since the last time that we had astronauts there on the moon with Gene and Jack, and to say that's far too long is an understatement. And so the Artemis missions we look forward to heading to the South Pole, and in these shaded or permanently shadowed craters, including one here near the center called Shackleton. These are going to be the areas that Artemis sets out to explore for a variety of reasons, including the possibility that there is water ice that is in those shadowed areas that we possibly could use. Also, this is a great place to be from a standpoint of long-term lunar habitability, because you can communicate with the Earth all the time. One of the problems being on other places on the moon is that you are, if you get in the wrong place, you're going to be facing away. Right? If you try to come over here to the far side, you're going to be blocked from communication with the Earth. We could stay over here on the near side, but there's a lot we want to know over here. So why not just come down here to the pole and be in a position where you can get to the far side, get to the near side, and communicate with Earth more or less all the time. So that's one of the reasons that's a priority. And here we have a some of you who enjoys physics may know the term name Schrodinger, like Schrodinger's cat. And this is the basin shown here. And this is shows a different kind of structure. This is over 300 kilometers across, by the way. Rather than having a central peak here, we have this series of peaks that form a ring, and there may be another more centralized area that's buried beneath some of the Maria lava flows there. And finally, as we look around to the far side, we see this very dark patch. That's actually a very low area called the South Pole Aitken Basin. And this is important geologically because we think it formed around 4.2 to 4.1 billion years ago, right at perhaps the beginning of that late heavy bombardment. More importantly, it has excavated deeper lunar crustal and perhaps upper mantle materials. And so while we don't want to go right to the center of that right now, because it's very deep, it's like 8 kilometers deep, the rim actually intersects over here at the South Pole near Shackleton. So we hope to gather materials associated with South Pole Aitken during the early Artemis missions. And with that, I'm going to actually zoom us out to a different place. We're going to head out to Pluto. And we're just going to visit quickly our 9 traditional planets here, plus 1, or 2, maybe 3, I don't know. The as we approach Pluto, we see the orbits of its 5 moons, including the special moon, Charon, right over here. And the others are just sort of lumps of ice, like Hydra and Nix and Styx, and Cerebus. But as we look here at the New Horizons data for Pluto, we see this gorgeous ice world with the impressive basin called Sputnik Planitia filled in with largely nitrogen ice. Around that, we have evidence of cryovolcanism and perhaps even flows of liquid methane or liquid nitrogen at times across the surface. This has a very thin nitrogen atmosphere. Either impacts or perhaps cryovolcanism on Pluto have led to ejection of material that goes over and lands on nearby Charon. And I want to include Charon tonight because it really is Pluto's twin planet. And some of that material ejected comes to land on the north pole here of Charon, creating this dark patch that sometimes in reflected light from the sun looks red because of certain chemicals called tholins that we believe are in it. And as we look around the imagery from the New Horizons spacecraft, it didn't image a lot of Charon, but it was able to get some really important areas, including some areas at the mouth of this canyon that some geologists have considered might be some sort of icy, slushy lava flows. And nothing like basaltic lavas here on Earth, but some sort of antifreeze-like solutions, perhaps that actually flow there or have flown at past times. And I was talking with someone earlier today about the Wizard of Oz, and if you're a Wizard of Oz fan, you might get a kick out of the fact that features on Charon are named for explorers of fiction. On Pluto, they're named for explorers of nonfiction. But here we see the large crater Dorothy for Dorothy Gale. She's an explorer, right? She was not in Kansas anymore. Well, she wasn't on Pluto either, but we'll name that in her honor anyway. And we're going to now go over to Neptune. And Neptune, of course, is one of our 4 gas giants made largely of gas hydrogen. Some people, though, call Neptune and Uranus ice giants because as you go down inside of them, and the pressure increases along with some differences in chemistry that we find at Saturn and Jupiter, namely that Neptune and Uranus have more nitrogen, they have more methane, Some of those compounds become icy materials, icy slushes under the pressures that would exist near the centers of these bodies. And so that's why they're ice giants. But here we see Neptune with its beautiful blue colors. All the colors of Neptune, or most of the colors of Neptune, I should say, because we do have some of those white wispy clouds and darker areas. Those are different chemical compounds, but the blues of Neptune, the aquas of Uranus, even the yellows of Saturn, and the yellowish brown white colors on Jupiter, all those are really there because of methane, natural gas, and the way that the light from the sun interacts with those out at different temperatures. So out here, what's really cold, we get these bluish colors. Of course, Uranus, we get the much more aqua color, and we'll go there just for a moment. And you see the orbits of some of its moons here. These are, there's actually, it was recently another moon of Uranus found, but it was just again, one of these lumpy pieces of ice. The ones you're looking at here are ones that many of us planetary geologists consider small planets going around Uranus. And again, you see the aqua colors there due to the interaction of the the heat from the sun on the methane molecules. There's some other a little bit more complex reason that you get these colors too that maybe I'll go into another time in the future. But of course, Neptune also is special because it is rolled over on its side, so to speak. It's we think long ago something collided with it that took the entire Uranian system and just turned it almost 90 degrees to the plane of the other planets. And we will go over quickly to everyone's favorite planet, Saturn, with its beautiful ring system. Did you know that its rings haven't always been there? It's estimated that they did not arrive until around 400 million years ago by presumably some icy worlds shattering and getting a little too close to Saturn and becoming unstable due to gravity, busting apart, and there you have these beautiful rings, more than 100,000 kilometers across the wheel there, so to speak, and but only a few kilometers thick. So these are very, very thin aspect ratio here, and again, you see the oranges of the methane. But most of this atmosphere is still made of hydrogen, which is colorless. So always keep that in mind. We see some of the storm activity at the poles, including the at the North Pole. We have this sort of hexagonal pattern. And as I mentioned, those rings, not always having been there, they're not always going to be there unless something replenishes them, because they are actually being consumed by the upper cloud tops there of Saturn. I'll bypass the moons there tonight. We mentioned, keep a lookout for Titan. Titan is typically, it's large and bright. It has an atmosphere that is composed largely of nitrogen, but no oxygen like ours. Instead, it has about 96% nitrogen and 4% methane. And but a lot of scientists think that it may sort of show the early chemistry of our own Earth's surface and atmosphere. We'll go over to Jupiter. And as we approach Jupiter, you'll also see the orbits of the Galilean satellites, the four special ones that, again, are really planets in their own right. Very active geology, including the volcanoes of Io, the oceans of Europa beneath its ice shell, and Ganymede, the largest satellite in the solar system, which quite frankly has a number of features that are very Earth-like in terms of almost plate tectonics, you will, but with an icy lithosphere. but also evidence of having an iron nickel core, like a terrestrial planet might. Jupiter here, you see some of the imagery from the Juno mission. Again, colorless hydrogen, colorless helium, but then you get to the cloud tops, frozen as ice crystals against space, and you see the yellow whites of ammonia, the reds and browns of cyanide and some other nasty organic molecules that you probably don't have anything to do with, and perhaps some little thin wisp of whitish ice crystals of water there as well. I'm going to just make a very quick stop in the asteroid belt at Ceres. Ceres is an ice world and the largest occupant of the asteroid belt, but it is differentiated into different layers. We know that because it has cryovolcanism. It has evidence of having some sort of liquid beneath it, and as you see there, that's just a blank view there. Here in our open space program, we can go over and choose different types of views, and we'll put a little bit of texture to that so we can see the data from the Dawn mission. And as we look here, we see evidence of lots and lots of craters, and notice they're very subdued. They're not very sharp, even though some of them are the right size. They should be very sharp. This is likely from sagging, over at least a slushy interior, a slushy mantle. And there are also, as I mentioned, some ice volcanoes here, like Kahuna Mons, a 4-kilometer tall icy shield volcano. And then we've already talked about our Earth-Moon system tonight for Observe the Moon Night. And we're going to now take a quick look at the innermost members here. Although the software may decide that it's going to end early for me. Just got a little bit of a view interruption here. There we go. Just trying to catch up with us there. And let's go quickly to Venus. Or excuse me, what am I doing? I'm totally neglecting Mars. How can I do that to our our god of war out there? And let's go ahead and take a quick look there at Mars. We'll notice the orbits of Phobos and Deimos, its moons, that used to be considered both captured asteroids. Now there's some debate about Deimos as possibly being material ejected from a collision with Mars and forming somewhat in the manner similar to our own moon. And we can come in here, and if I can find the line things up right, we might be able to see where our Perseverance rover is right now. See if we can identify a few features here. I'm going to turn the shading off on this one, I think. Maybe not. It's not going to let me. Let's zoom in here and just see what we can find. You see a number of impact craters. This is a kind of the spacecraft raw imagery here of what you'd see without a lot of the high resolution detail if you were flying above Mars. And there you see one of the ice caps here with the sort of swirled icy glaciers. And we will finish up very quickly with Venus and Mercury this evening. And Venus, of course, is a searing hot world, not because it's particularly close to the sun. It's closer than we are, but it's still not super close. But the issue really is that it has a very dense carbon dioxide atmosphere with a incredible greenhouse effect. So almost the entire planet is constantly between 400 and 500 degrees Celsius at the surface. You have to peer through the thick clouds of this world, which are made largely of sulfuric acid laden water. And as we look through with radar, we see these very rugged terrains that are called tessera, and we think these might be akin to Earth's continents. This round feature is not tessera. This is a what's called a corona that we think is an area where hot asthenosphere, like here on Earth, is upwelling underneath and in the mantle, causing extension that causes those circumferential cracks. And many of these features you'll find volcanism near their centers. There are also plenty of large shield volcanoes here on Venus, and there are a few large impact craters. I believe this is Meade here, which is the largest one. But you can see areas that are standing up very bright at the center, and then these lava flows coming down. We now know that some of these lava fields are still active. This is something that we will hope to investigate with future missions, largely peering at this again with radar. It's very tough to land anything here, but you see these lava flows that can extend out very great distances because they don't cool off very quickly in that hot, searing atmosphere. And finally, speaking of hot and searing, let's go over to Mercury. Mercury is not as hot on the surface as Venus because it doesn't have the atmosphere, but it gets plenty hot on the daytime side, up to around 425 degrees C at its equator. But it rotates around, and so it has a nighttime side, a daytime side. So on the daytime side, it's awful hot. On the nighttime side, it's awful cold, dropping down again to around minus 125. A little warmer and dark here because it's closer to the sun. And it looks very moon-like, right? And that's what most people notice, but it really couldn't possibly be more unlike the moon. You don't see the large basins that we have on our neighbor. Instead, you see lots of craters, some that are very large. And this surface is largely a basaltic surface, but the whole thing goes back to more than 4 billion years old. And some of the lava flows that we see here, rather than filling the Great Basins, are just huge flood basalts that come out across the surface and bathe the crust, and in places show evidence of being so fluid, so runny, or what we call low viscosity, that they behave more like water than they do lava, and actually cut through pre-existing lava flows. So that's one of the fascinations here. And you do see some relatively young craters. There's one with very bright ejecta. And my thing I'll end with this evening is, what do you think this gets hit more by? Asteroids? Comets? This is a long way away from the asteroid belt, so we actually estimate that up to as much as 70% or so of these craters are caused by comets that come in very close to the sun in their parabolic orbits out of the deeper recesses of our solar system. And Mercury's going around very quickly, sweeps out a year every 90 Earth days, and so quite often is in the way of some of those comets. So with that, I'm going to come back here, and I'm going to leave you with just one other view here, and give me just a moment while I call this up, and I'm going to show you a very special picture. On Observe the Moon night, I'm going to invite you not to observe the moon at all. But if you ever want to see a place that is a replica of the moon, or at least a replica Apollo landing site, this is called Cinder Lake, just outside of Flagstaff, Arizona. And this is an area where the NASA and the United States Geological Survey back in the 60s and 70s, to test the lunar rover, detonated charges to recreate a scale model of one of the landing sites to drive the rover, called the rover, out across the surface. And if you go there today, it's been messed up a bit by recreational ATVs, but still many of these craters are there, and you can imagine yourselves being ejecta there. And that's a very special way to think about the moon. And we will end with a real view of the moon there with our Apollo 11 landing site as seen by the Lunar Reconnaissance Orbiter and the LROC camera. And so with that, I will see if I can. I'm afraid I did not get that up there for you. Let me see if I actually may have just not caught that there. Let me go back to that for you, because I really want you to see this. So this is the actual landing site. Go back up. Oops, sorry. This is the actual landing site. Let me call this up again. And there we go. So there's the actual Apollo 11 landing site. And if I go backwards, that is not the Apollo 11 landing site. That is an area in Cinder Lake outside of Flagstaff, Arizona, as I said. And these are mock-up craters, and you can see the whole thing that was created back there in the 60s to test the rover. So again, if you have an opportunity to be in the Flagstaff area, you might want to take a look at this. Also go in and visit our friends with the United States Geological Survey's astrogeology branch, a very important group there, mapping our solar system in Flagstaff, and also doing a lot of fundamental work on understanding the geology of our neighboring planets and our own planet. So with that, I will again say thank you for joining me for the our Observe the Moon night. And if you're watching this in a recorded version, please do ask any questions, either by putting it directly into the live chat or emailing me at southernspacerocks@gmail.com. I'll be happy to address any questions. Again, I will be back here. We're going to try to keep this going, being back here with you for the At Home Planetarium show that I was very happy to do for much of the pandemic, and tried to do a few times, but we're going to do our best to bring this back to you and have some guests coming up in the future so that we can explore even more of our solar system and the universe beyond. So with that, again, thank you very much. Signing off for the evening. Again, if it's clear where you are, go out and enjoy the moon. If you can't do it on Observe the Moon night, do it any other night. It's a gorgeous neighbor that we have, and life on our planet literally wouldn't be what it is without it, as it stabilizes our obliquity, our tilt. It actually keeps us from rocking back and forth that would create a climate that probably would not be hospitable to life. So with that, have a wonderful remainder of your weekend. Good night. Bye-bye. See you next